Welcome everyone. Imagine a world where our computers run at lightning speeds, our smartphones charge in seconds, and our electronic devices waste almost no energy. So I am talking about what? I am talking about devices where electron mobility is extremely high and conductivity that is ultra fast. Only in that case that this would become possible. That means our computers would be able to run at lightning speeds. Our smartphones could be used to charge only in seconds. Okay, and electronic devices, many electronic devices we use in our day-to-day life, and those electronic devices actually at present they are wasting much energy. Maybe that is not known to you, but by using such things where mobility and conductivity are extremely high, in that case electronic devices would be able to waste no energy, almost no energy. No energy, that is wrong, but almost no energy. Means they will waste very less energy. So all these things are possible due to the discovery of graphene. Graphene is what? Graphene is not a metal. It actually acts like semi-metal, graphene. It is made of a single layer of carbon atoms arranged in a hexagonal honeycomb pattern. Yes, single layer, only single layer of carbon atoms are there in graphene structure. So there are so many properties, special properties exist in graphene, but those things won't be discussed here. Here for this purpose, here the topic of discussion is what? Here the topic of discussion is graphene's massless electrons. You know electrons are having mass. Masses are very small, but still they have mass. And if they have mass, so what is the meaning of that? When you consider the electrons have mass, that means if you apply force, means driving force to move the electrons, so what is the result? Depending on the magnitude of the force, electrons will accelerate. That is known to you. Means acceleration of the electrons depend upon the driving force. And here in this case of graphene, electrons move at constant velocity. And what driving force is actually applied? Electric field is applied. So electric field is applied in case of copper. There also electrons move. In case of aluminium, there also electrons move. Again, if you talk about normal semiconductors and transistors, they are made of what? You know that thing, they are made of silicon. So there also electrons move. But if you consider in the world of electronics what are used, in the world of electronics at present silicons are used. Means that today's electronics is silicon based. So now if you compare silicon and graphene, then you will get astonishing results. In case of silicon, the electron mobility is of the order of 1400 square centimeter per volt second. 1400. And the same for graphene is how much? It is 2 lakh, means 200,000 square centimeter per volt second. I am talking about electron mobility. Electron mobility means how easily electrons move through a material when an electric field is applied. That means you can see just by looking at the numerical result, 2 lakh and 1400. You just take the ratio. It will be more than 100, the ratio. 2 lakh divided by 1400. Or 200,000, 2 lakh, in India this is used, actually 200,000, okay, divided by 1400. So you will get what? Astonishing result. It is more than 100. So this is the difference between silicon and graphene. That's why the graphene has become so important. And that's why companies and research labs are exploring new ways to integrate this graphene-based electronics into the existing ones. You know, Moore's law has Moore's law already has approached its limit. Means today's silicon devices or silicon transistors are struggling to get smaller and faster. Only the next technology, means this can be considered as the next gen semiconductors. Semiconductors are required, but with much higher mobility, electron mobility rate. So why these things happen? Actually, what happens in case of this graphene, there is a formation of Dirac cone. And due to this formation of Dirac cone, electrons act like massless particles. That is the most fascinating part for super fast transistors, or you can say in terms of technology that super fast processors or super fast quantum computing components. Okay, everything will become super fast. Wherever there is a processing of information, all those things would become super fast due to the use of this technology, due to the use of this special material graphene. I have already mentioned that this is not a metal. In metal, conductivity is much higher. In metal, like a copper, aluminium, silver, gold, these are metals. Here, in metals, you know that conductivity is higher than semi-metals, and graphenes are considered as semi-metals. But if you talk about the electron mobility, then electron mobility in graphene is much higher than silicon, gold, silver, copper, aluminium, etc. And due to this incredibly high electron mobility, graphene has become so important for tomorrow's electronics. Okay, so this was all about. So what is the advantage? Why electrons mobility is so much higher in case of graphene? Answer to this question is there is a formation of Dirac cone. Means electronic structure is like that. There is a formation of Dirac cone in graphene material. And due to this, electrons act like almost massless particles. That means depending upon the electric voltage, velocity does not exist. Velocity doesn't exist. There you will get a constant velocity in graphene. Means it is irrespective of the magnitude of the electric field being applied. But in case of silicons, the electron mobility depends upon the magnitude of the electric field applied. Okay, there is a difference. And in case of graphene, the electron mobility, this velocity is constant, and this is known as Fermi velocity, and the magnitude of which is 10 to the power 6 meter per second. And you know what is the speed of light? That is known to you. It is 3 into 10 to the power 8 meter per second. So if you take the ratio speed of light divided by speed of if you take the velocity of light divided by Fermi velocity, then ratio is what? 3 into 10 to the power 8 divided by 10 to the power 6. 10 to the power 6 is the Fermi velocity. Means at this velocity, electrons move inside the graphene material. So what is the ratio? 3 into 10 to the power 8 divided by 10 to the power 6, which is equal to 300. That means in graphenes, electrons move at a speed of 1 by 300 of the velocity of light. That means incredibly high speed exists. And due to these high speeds, the electronic components, electronic processors would become super fast. Okay, so this was all about today's topic, graphene's massless electrons. Okay, actually not massless, but electrons behave as massless particles inside graphene material. Okay, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.